In this video, we're going to look at some other ways that we can compare fractions using reasoning. In our previous videos, we looked at using 1 as a benchmark. In the second video, we looked at using 1/2 as a benchmark. But what if fractions are not really close to 0, not really close to 1, and not really close to something common like 1/2? So here's an example, 10/13 and 9/14. These are not really close to 1. They're not really close to 1/2 or some other kind of common fraction. So let's see if we could reason with them in a different way. One way that we can reason about fractions, and it may work for some pairs of fractions, is to compare the number of pieces and the size of the pieces. So the numerator tells us how many pieces are in a fraction. 10/13 has 10 pieces. 9/14 only has 9 pieces. So 10/13 has more pieces. Now, just because it has more pieces doesn't necessarily mean it is greater. It also depends on the size of the pieces. So the denominator tells us about the size of the pieces. 1/13 is a bigger piece than 1/14. 13ths are bigger than 14ths. So 10/13 has bigger pieces than the 9/14. So if 10/13 has more pieces and those pieces are bigger than the pieces in the other fraction, then 10/13 must be the larger fraction. Let's see if we can use similar reasoning with this example. We have 8/13 and 9/14. So first let's look at the number of pieces that they each have, and that's by comparing their numerators. Well, 8/13 has 8 pieces, 9/14 has 9 pieces, so the 9/14 has more pieces. Let's also look at the sizes of those pieces. The first fraction has 13ths, while the second fraction has 14ths. Well, 13ths are bigger pieces than 14ths. So putting that together, we see that 9/14 has more pieces, 9 pieces, but 8/13 has the bigger pieces. So then the question is, which fraction is bigger? Well, this type of reasoning won't really help us decide that because one fraction has more pieces, but they are smaller pieces. We can't really make a conclusion based on the size and the number of pieces. One thing that you may have noticed about these particular fractions is that they both have a difference of 5 between the numerator and denominator. In other words, they are each 5 pieces away from a whole. So 8/13 is 5 pieces, 5/13 away from one whole, while 9/14 is 5/14 away from a whole. Now 5/14 is smaller. That's a smaller amount than 5/13. So that means that 9/14 is a little bit closer to one whole, and that means that 8/13 is less than 9/14. Now, what would have happened if they weren't exactly both 5 pieces away from a whole? And maybe we couldn't compare them to 1/2 or some other kind of common benchmark. Well, that's when we really do need to use other strategies like common denominators or decimals or percents. Sometimes fractions are so close together, or they don't necessarily have much in common, and we may have to use one of our formal methods in order to compare them.